Yes, this will continue, children. Good morning, everybody. There are good number of problems under the same heading. So just tell me where we were previously. Problem 5 was over, right?
Yes.
Now 6th one, right? Now look at this. There is a cube, every side of which has one resistance R. Okay. How to find out the equivalent resistance between A and B? So once again, this is a symmetry. This is a circuit with symmetry. When you simply flip it, it looks like same. You understood what I told? A is here, B is there. Just simply turn it. Nothing would change. That is looking at the circuit as a whole for the symmetry. Okay. Now, what shall we do? We'll think of connecting this to a cell between A and B. All right. So can I straight away start saying plus V minus V? Tell me, children. At least one of you keep talking. So I can say this is plus V, this is minus V. Is it okay? Is that visible? Is that visible or some other color I should use? This is plus V, this is minus V. Now look for the symmetric paths. I told you first look for the symmetry of the circuit as a whole. There's a small difference between these two things. There's a small difference between the circuit being symmetric between 2 points to finding out the symmetric paths. As I keep doing, I'll keep showing you in various problems. Now, for that I told you, start from the entry point. Where is the entry point here, children? Entry of what? Current.
A.
Where is it entering here?
A.
It is entering, right? Now, from here to exit point, that is B. The current will come back to minus the cell, right? That's how we put one cell. If I put, it goes out and enters there and comes in like this. This is how you need to look at any time. One single cell circuit we have. This is what I've told you to do. Isn't it? Huh? So, from entry point to the exit point, look for paths which have got identical minimum number of resistances. So this one is one path. This one is another path. This one, like this one, you can go that side or you can come this side, doesn't matter. This is another path. So 3 paths have got identical resistance of R each. I cannot have gone in some funny direction to reach the point there. Like for example, you might say, sir, can I not look for a path like this? No, you should not. You should look for the minimum number of resistances but identical in all the 3 paths you search for. Is it okay? Tell me, children. Khaja?
Yes, sir.
Now, therefore, you divide the potential equally. One side plus the other side minus all the time. So, can I say this will become plus V1, this will become plus V1, this will become plus V1, children?
Yes, sir.
And similarly from this side, minus V1, minus V1, minus V1. So all the points covered? Huh? All
Yes.
the points covered?
Yes.
The nodes covered, isn't it?
Yes, sir.
Yes, sir.
Now, the first way is the best way, the junction. Hmm? So what is it? 2V by R effective. 2V by R effective equals what? Shall I write
Three
V
times.
minus
V minus
V minus V1 by R.
V1 by
R.
R? Is everybody okay with this? V minus V1 by R plus V minus V1 by R plus V minus V1 by R. I need not to show it. It's there visible. Where? This one. This is V1, V minus V1 by R. That is V minus V1 by R. That is V minus V1 by R, isn't it? Huh? Aditya. Isn't it so, children? So, second equation, where will you write? Somewhere else. For example, here I will write. Can you see this? Whatever I marked here? You can. So, for that, what will I write? Current goes like this. From here, divides into these two. Is it okay, children? Huh?
Yes, sir.
So, what will I write? Come on, tell me, one of you.
2
G1 by
V minus V1 by R.
Minus V1 by R equals
4 V1.
huh?
4 V1 by R.
Together. V minus minus
4v1.
huh?
4 V1 by R, sir.
Straight away I'll write. Okay.
Yes, sir.
Let's cancel. So what do I get? V equals
5 V1.
1 is V by 5. Go back to this. So 2V by R effective equals, what did you get? 3 into, in the place of V1 I should write V by 5 by R. So 2V by R E equals 5V minus V, 4V by 5, right? 3 into 4
V by 5.
5 by R. This is 3. 2 times 1V goes. So what am I getting, children? RE equals
5 R by 6.
R by 6. This is the fundamental way of doing this. All right. Now, any question here, children? Most simple question, this one, but this is the first way of doing it. Actually, remember, I've told you something. In a simple series parallel circuit also, the Kirchhoff laws are applied, whether you knew it or not, I told you. In a similar way, I can tell you, whatever way, you'll say, no, I'll do it this way, I'll do that way because you've seen it somewhere. It doesn't mean that there's a different method. Try to understand. Anytime anybody would do it with currents, even for that, they should have decided the potentials first. The whole game of the circuit analysis is that. You need to define, you need to find out, you need to put the potentials first, and then potential differences. So the one defining what you call a rule for the whole lesson, defining a trick for the whole lesson is that, believe me. And that should become a habit. Okay, now, but the same thing, how could I do in some other way? Look at this. I'll go for the next slide. It's not problem 7. Let us say it is the same problem continues. Just go back again. Why this is not changing? Just a minute. Anyway, this is not problem 7. The same thing continues. What is that problem? 6. But I'll remove B here. I'll put B there as usual. We decided until now that this is plus V, this is minus V plus V1 plus V1 plus V1. All right. Minus V1 minus V1 minus V1. I can divide the currents now. I think this is my cell. I current comes out, I'll think. Huh? And how much this potential difference here I could write? Sorry, not there. Just a minute. This one I'll remove. Yeah. Now let me write first of all. If I enters like this, can I write it as I by 3 here, I by 3 here, and I by 3 there, children? This
Yes,
is
sir.
all across the symmetry is maintained. If there are 3 resistances equal, there you can't divide. From this entry to exit point, the same symmetry is maintained. R, 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 R. Then I can divide like this. I by 3, I by 3, I by 3. Now, will it become I by 6 into this and I by 6 into this, children? And similarly, I by 6 into this, I by 6 into this, I by 6 into this, I by 6 into that. Now, this I by 6 and this I by 6 should become I by 3 here. This I by 6 and this I by 3 here. This I by 6. Where is one more thing? Yeah, over actually. I by 6. And here, yes, this I by 3, this I by 6 should become I by 3 here. So I by 3 here, I by 3 there, I by 3 here. That's what you mean by symmetry. That means if I connected plus that side also, the same thing will be valid. So let me write Kirchhoff's voltage law. Apply KVL. For example, I'll show it by highlighter there. I do not have to put anything. Which one? This one I'm writing. Can you see that? This one.
Yes, sir.
Yes, sir. So now for that, if I write, what will I write? Look, in the direction of current when I go, you've seen the loop already. I'm writing straight away. Minus I by 3 into R. Minus I by 6 into R. Minus I by 3 into R. If you go like this, but what will be this potential actually? The whole thing is, for example, R effective. The way I move, it becomes plus I into R effective. The whole circuit is having R effective plus I R effective. I am going from minus to plus. Is it okay, children?
Yes, sir.
That is equal to 0. So R going away. Sorry, I mean which one? I going away. Look at this. This one you remove. This one you remove, and I on all the sides going away. What will you get? RE is 5R by 6 only, isn't it? I by 3, I by 6, I by 3. Shall I write it or shall I write straight away 5R by 6? So this is one more way. That is applying after dividing potentials. You can also divide currents. There is third way. Since you decided the points of equal potentials, you can also reduce the circuit to series and parallel. I just draw the circuit and show it to you. Just recognize whether you understood it or not. Even this is agreed or not agreed. Many people do like that. I prefer just directly applying the junction rule and doing it because There's no point in just looking at all the things and drawing a circuit. Lot of time it takes. If it is a new problem, no one is okay. New little complicated problem. Instead of trying to look at in terms of series and parallel after putting potentials, just apply the junction rule and do it. That will take care of the things. So this is point A, this is point B, children. So this is point of plus V, this point of minus V. This is points of plus V1. These are points of minus V1. Can you see in the circuit? I did not name them because already crowded. You could give some other names, A, B, C, D, E, F, G, H, all that you can put. And say that we connected the points of same potential. This one, this one, this one at one place, this one, this one, this one at the other place, and all the other 6 in the middle. So this will be in parallel, R by 3. This is in parallel, R by 6. This is in parallel, R by 3. The total is in series. So this is the third way. So which one do you want to follow? That is left to you. Whichever is convenient to you, you can do that. So the problem 6 continued. Tell me, children. So, but remember, the recognizing the potentials comes first, after which what you want to do is left to you. But remember, which one to do, how to do, it comes only by lot of practice. It doesn't come just like that. But remember, these are all standard problems. So once the results are known, you can as well remember the results. I have no problem with that. But that should never make you think that there are some fixed number of problems for which I'll remember all the results. Do it, get the answer in all the ways, then remember the answer. Then you're ready for doing a new question. Because what happens, sometimes the standard results can be used to reduce the sums later, reduce the length of the sums later. So any questions, children, here? Gautami, Anurima, Vaibhavi, one of you speak. Avinash? Children, if you don't speak now, these problems, you will have trouble later. You will say, Samir sir, those problems I did not follow that time. Tell me.
అర్థమైంది సార్.
ఎవరు మాట్లాడింది? గౌతమియా, అనురిమనా?
గౌతమి సార్.
గౌతమి. అనురిమ రావట్లేదమ్మా క్లాస్కి?
వస్తున్నా సార్.
వస్తున్నావా?
Yes, sir.
Why are you not opening your mouth? Look, if you don't respond, I have to suspend some problems. I have to suspend doing some more problems because they are better ones. No, isn't it so? Like say you're not following. Why should they trouble you people? We can come to those problems later when you're ready for it. Actually, you need to understand the teacher's job is to analyze here, not actually write every solution. Then you're actually on the path for success, believe me. You need to take a little clue. And in fact, once the basic idea is discussed, you should not allow the teacher to do. Then you should ask, no, give me some time, I'll show it for you. And somewhere you get stuck. Then you will ask, what is this thing? What is happening here? Just look into this. But in spite of my calling you so many times, people are just not speaking. At least I told you to say yes, sir, so that I know that you are there, right? Whether you get it or not, that's not a big deal. Okay, now we'll continue. This problem. Who is coming now? galaxy. Is somebody asking for permission? I don't see anybody here. Okay. Now, let me just this I'll remove. I'll put it. Why it's not going? So this, not this one. I'll do this one for a while between A and B. Now, people tell me. One of you please start taking the lead. Now I can make these things very interesting if you speak. Otherwise, I'll be doing it for myself, right? I've done it some thousands of times by now, right? Huh? Come on, what should I do? Is there symmetry here?
Yes, sir.
Yes, sir.
Naturally, obvious, isn't it? There's a cube, all R's. Huh? So whichever side, whichever point, 2 points you say, there is some kind of symmetry. There's no problem with that. So this is plus V minus V.
Yes, sir.
After that, what should I do? You tell me.
You should put V1 and minus V1.
This one, this is the other. That's why we took it plus V minus V. Then, child, what should I do? Tell me. What could I do? Guess something. Let it be wrong. No, nothing to worry. Plus V minus V we could put. After that, there are many more points where I need to put the potentials up. Probably to be more general, can I put, say, some plus V1 here? Or can I put directly 0 there? I'm not sure whether I can put 0 because there are other things, right? Huh? So I'll put minus V1 plus V1. Is it okay? Can I do this or not? There's no B here. Oh, please tell me, come on. I want you to say something.
Sir, it will be plus V1 there.
Some of you need to speak, otherwise. Which one is plus V1, children? This is plus V1 I'll take. This also I'll take plus V1.
Yes, sir. And one more point.
Here also I'll take plus V1.
Yes, sir.
Are you sure?
Yes, sir.
Other children, like, can you get, like, see, V2 plus V1 I went. V2 plus V1 I went. Here also plus V1 he's saying I'll take it. And then tell me what? Minus V1? Huh? Isn't it so? People are not telling me what to do.
Yes.
I'm giving you the opportunity to make mistake. Between this, these are the entry and exit points. I connected one cell like this. Okay. So that's how things are going. So Sai Kiran is suggesting like this. Can I put like that? Let us put and see. Minus V1. Minus V1. Okay. Sai Kiran, are you okay with that?
Sir.
Sir, it will be 0 there now, sir.
We can prove it actually. It will be 0 actually, but supposing I don't know, now we can decide that to be. But is it in general right or wrong?
No, sir. Minus V2, sir.
Where?
अगर potential मात्रा sir.
Where? You mean to say here plus V1, here plus V1, here plus V1 is okay, but something else is going wrong?
Yes, sir.
Tell me how. This one. That one is the key. Huh? I'll rub off that, you tell me again. I'll rub off all this which I put. No, if I give, I'm telling you children, there are good questions again. If I myself just give the potentials, you will never know why am I putting potentials. Huh? This is not the point we wanted, is it? We wanted that other point. That's not going, it's already there. So I'll just take this out, put B here. Now this is plus V1, this is plus V1. All right, but how about this? Srikanth, P Srikanth, you told plus V1 there also. How? Why don't you look at it? If you are going, if plus 1 you put just A to B, you go, this is okay. This is okay. From here, where are you going? To B.
Yes, sir.
Huh? So I should write plus B2. Is it okay now, children? I was waiting for somebody to catch and tell me. So in which case, what will I do, children, now? Huh? For the next one. For B, what should I do? Can I say minus?
Sir, in the
Why don't you speak, children? You have, otherwise, no, I'm not going to put anything. From B, how should I do?
Sir, those two will be minus V2, sir.
Which two?
sir, adjacent point of B, sir, that would be minus V2.
This one?
That will be minus V1.
This one?
Yes, sir.
All right. Then the other two? Other two, what should I write?
Sir, that one is minus V1, sir.
Which one? This one?
Yes, sir.
I want you to look from this side, and these are the 2 points, children. I'll put once again the battery, but that will become crowded. Now tell me. Actually, they are going to be 0, basically. But supposing I put it and prove it, that will be even more powerful. Only, no, even to put 0 also, you should just check for that symmetry for a while. After that, you can convince that yourself that it is somewhere it's going to be 0. This is our plus V minus V. I did not put. This is plus V over. This is our minus V. So what shall we do? Pick. Plus V1 plus V1 plus V2. So from B.
Sir,
Speaking.
sir, from plus V2, the current is passing 3 resistors to reach B, no, sir. In the same way, from this adjacent point to B, it should pass 3 resistors to reach A. So that should also be minus V2.
Which one? The one we rubbed off?
Yes, sir.
So then why others were not agreeing for that? The image of that. Come on, others are not speaking. Himanshi, Bhavana. There are 10 more questions like this. Believe me. I will be motivated to do them if you people get into doing along with me. Actually speaking, you're going from plus V to, look at this. Like this we are going, like this we are going. Plus V to minus V through two resistances. Huh? So naturally we'll put 0 here. We can put 0 actually speaking. But there are other things attached. Unless I prove that it will be similar to this can be maintained even if I come from that side, I cannot. That's the reason I was just asking you to look at plus V to minus V, plus V to minus V through 1, 2 you're going, 1, 2 you're going. 0 I could put directly, but the same thing I should be able to tell for the other side also. Then job is done. You can put directly 0. Otherwise, you can put some values and then write the junction rule and prove that it is 0. That's how you'll get into mood for these questions. So how will I go about it? What's happening, children? Why don't you speak? Why don't you speak? I know the answer. I know everything already in advance. I know. So what's the point? What do you want to do? You tell me. This or B. So plus V minus V. Then P cycle. Why are you not speaking? Are you there, children? Online?
Yes, sir.
Sir.
This will be the situation basically. You understood the direction I went now? Look at this.
Yes, sir.
Plus V minus V put. I said this is plus V1. I then put minus V1. Is it okay? Because of this, since I can go from plus to plus 1 V1 to minus V1 0, I can put here plus V1 to 0. I can put 0 here. Same thing I can do for this side and that side. This is the side we have, right? This is the side we have between these 2 points. I should find out my I should put the potential. So this one and that one are the symmetry sides. So if I put plus V minus V here, I can put some plus V1 minus V1 there. Immediately I can tell you that this will be 0, this will be 0, this will be 0, this will be 0. Tell me now. Huh? Come on, children. Why don't you speak? So that's how the points you go on putting. Otherwise, what will you do? After putting plus V1 minus V1 here, you can put some values there. Some plus V2 minus V2, plus V3 minus V3, plus V2 minus V2, that side you can take like that. And then the mass will prove it. Now, people are not speaking, so let me complete the question. So what should I write now? For the current centering, 2V by R effective equals, what should I write? Are you there, children?
Yes, sir.
Yes, sir.
Then what should I write for this? 2V by R effective equals, what should I write?
2V by
V
R
minus V1 by R.
2V by R
plus
V
V minus V1 by R.
plus V minus V1 by R. And then some other point. V minus
V1
V1 by R equals, tell me.
V1 by R. 2 times V1 by R.
V1 by R.
Huh?
2V1 by R.
2V1 by R. Is it okay?
Yes, sir.
So R going, V equals
3V1.
1. Right? So 2V by R effective is equal to
3V1.
2V by R effective equals, did we write it previously correctly only? Yeah. 2V by R plus V minus V1. V minus V by 3 R. So what do I get? 2V by R plus 3V minus V. 2V by 3 R. Is it okay?
Yes, sir.
So what do I get now? 1 by R equals 1 by R plus 1 by 3R. Is it okay? So RE equals how much? 3R by
3R by 4.
I'll keep it open for you for some time. You tell me. What I was trying to tell you was, I don't want to crowd this again. Plus V1 you took here. What you can do is now, plus V1 minus V1 you will take there. You can also take some plus V2 here, plus V2 here. Tell me. Minus V2.
Minus V2 minus 2.
Like that you can do. And you'll show that when you write the equations, V2 equals 0. But that requires one more equation to write. Do you follow? Tell me now.
Yes, sir.
Yes, sir.
So it comes with little observation and practice. But for that, you need to keep experimenting. You keep at least doing some hit and trial also. I mean, at least minimum thing. And we can also reduce this to series and parallel if you want. What it means is reduce in series and parallel. You will start from here. The 3 resistors are there, 3 resistors are there. In the middle, see how to connect those points of same potential. But once this is already over, actually, I don't really feel like going there. Tell me, children.
Yes, sir.
So can we go for the next question?
Yes, sir.
Right. Now, look at this. The same cube you take. Actually, you can simply draw straight lines, say that each of them is one resistance, but to get a full feel of that, I'm putting all the resistances here. what I was trying to do. Just you can draw straight each without putting the symbol. You can just simply draw lines, straight lines, and say each of them has a resistance R also. Now, what was the thing here between these two ends of a side here? Now, previously it was between the ends of a body diagonal, then between the ends of a face diagonal previously. Now it is between the ends of a side. So tell me, children, what should I do? Just take a risk, let it go wrong. We'll see.
Sir, at A plus V and at B minus V.
That we can still do, right?
Yes, sir.
Plus V minus V. Now.
And top of A plus V1.
Just a minute. Plus V to minus V, how am I going? This way I'm coming.
We can go there. And this front face also the same, sir.
Front face also is the same thing. So
Yes,
that's how we need to look at every time. So tell me, Sai. Say I can say plus V1.
Plus V1 minus V1.
And where is the other plus V1?
At that opposite corner.
This one?
Yes, sir.
This is plus V1, children. This is one path. This is another path. So this is
Plus V1.
And this is
Minus V1.
Minus V1. And which one is the other one? This one?
Yes, sir. That is minus V1.
Minus V1. Then what will be this? Some plus V2, we don't know.
Here minus V2.
And here minus V2. But remember, since V1 was greater than V2 the way we thought, here minus V2 should be greater than. Isn't it so?
Yes, sir.
3 is greater than 2.
Minus 2 is greater than
minus 2 is greater than minus 3 for the current sake. You understand what I told?
Yes, sir.
Current flows from high to low potential, isn't it so? So tell me one equation. 2V by
2V by R effective is equal to 2 times
2 times V minus
V1 by R.
R and
2V by R plus 2V by R.
Plus 2V by R because current goes into this also.
Yes, sir. Yes,
yeah,
sir.
now you are on the path, correct. And second.
Second is
you write here.
V minus V1 by R.
V minus V1 by R.
Is equals to V1 minus V2 by R plus 2V1 by R.
Plus
2V1 by R.
So now he has understood things. Now third. Shall we write
V1 minus V2 by R is equals to
V1 minus V2 by R is equal to
V2 minus V1 by R.
Just 1 second. So V1 minus
The current is going down, sir.
V1 minus V2 by R equals plus
V2 minus.
సరిగ్గా చెప్పు. ఇక్కడ ఏం చేయాలి?
Sir, 2 times V1 minus V2 by R.
V1 minus V2 by R, and this also going that way. Sai.
Sir, I'm dividing that current into those two. Okay, understood, sir.
Oh no, you cannot come from V2 to V1. You'll go from V1 to V2 because
yes, sir. Yes, sir.
V1 is greater. So V1 minus V2 by R here.
V2
plus
V1 minus V2 by R equals to 2 times.
Isn't it?
Is equals to 2V2 by R.
After that, 2V2 by R.
That is it. Yes, sir.
So do you all agree for this? Gautami, Anurima, Khaja, Himanshi.
Sir, in second one, 2V1 by R.
Second one?
2V1 by R he wrote.
Let us see. V minus V1 by R. This one he wrote, right? So V1 minus V1. This is a junction, dear. current is entering. This should leave, right? So V1 minus of minus V1, AV minus V1 hai na idhar, Khaja.
Only one no, sir. V minus V1. V minus of minus V1.
So
Okay.
what,
Yes, sir. Understood.
that by, that by R. Please quickly calculate and tell me. Don't ask me to simplify this also. Let me see who will get it fast. No, there are better questions actually, even more better questions than this. So you have to respond. But remember, any other method like series, parallel, all that people try with this, that we may do a mistake somewhere if you don't look at properly. Just put potentials, write the junction rule, over. You need to be a little quicker in your calculations, otherwise it is going to be simple. So is that all right, everybody? Writing the equations. Imanshi, you're not speaking at all. Are you there?
Sir. Yes, sir.
Harshini.
Yes, sir.
Amma, while putting potentials, I want you to do mistakes. Then you'll really understand. Otherwise, no. Impossible. Because for this sum, I should take like this. For another sum, how will you do that? So by doing mistakes only, here people understand where to put what potential.
R effective is 5R by 8.
5R by 8. Something is going wrong. Check with the potentials otherwise. Let me see. I'm waiting for one more.
7R by 12.
How much?
7R by 12.
Anirimana, Gautamiya.
Harshini, sir.
Harshini. 7R by
12.
12. I hope you got the answer now, not the one you remembered previously. Emma? Harshini?
Yes, sir.
You got it now solving these equations, or you are giving me the answer you remembered?
I solved it now, sir.
Okay, right. This is the answer. Now, the same question. People, come on, finish it off.
Yes, sir, 7R by.
Yes, sir.
Others confirm it.
Yes, sir. Yes, sir.
Srikanth Reddy, are you coming every day?
Yes, sir.
Are you following these things?
Yes, sir.
I told you already. Now you have no excuse. Like yesterday's one, something went wrong, but even this I'll put up there. You watch it. There's nothing like not following it if you watch it for the second time. All right. Can I go to the next one? Those who are still trying, try it later. I'll go for another question. Now I'll just do something. I'll give a question, same question I'll give you, but I'll give you time to do for yourself. I'm not going to join these two. Everything else is our children. Okay. Now get your answer at one go. What did we do compared to the previous question? We simply have no resistance here between A and B. So everything else remains same. In fact, you could use old equations if you wanted, if you're smart. So if somebody is using old equations also, you could tell me what's the first one, second one, like that. As you're writing, you can also tell me. What is going on? Raja, will you try?
Sir.
So you want me to tell how to put the potentials?
Sir, I will try to say, sir.
Tell me. At A plus B, can I write?
Yes, sir.
At B minus
B.
B, can I write?
Yes.
Then what? This one,
Adjacent to B minus V1.
this one is one path. This one is a similar path. Isn't it so?
Yes, sir.
Tell me, what should I put here? Plus V1 can I put?
Yes, sir. We can put
Then where should I put plus V1 further?
down also.
Here also. Then
It means minus V1.
minus V1. Where else I'll put minus V1?
Upside here from B upside.
This one. Then इधर क्या रखना मैं?
There we can put V2.
Here
Minus V2.
बस. Isn't it so? So equations बोलो ताजा. 2V by R effective कैसे भी आएगा, right?
Yes. Sir, there is no. We are not joined us.
No?
Not joined us, sir. We are A to B. We are not joined.
Way to be, we join with a battery child. That's why I was asking you children, you need to speak. If you speak, actually, you will see within 15 days, you will be different actually. Now, he's saying something. Come on, tell me. Others.
Yes, sir. 2V by R is.
क्यों? अब change क्यों किया?
Sir, when we join battery, then it passes to redness.
We put a battery here, right? Like this. So all this is one RE, Khaja.
Yes.
So plus V minus V potential difference hoga. That by RE is the only current entering here, no?
Yes.
So you, next time when you write, you won't take this one. You'll only write those two. 2 into V minus
V1 by R.
R. That second term in the first equation which you wrote in the previous problem won't be there here. Isn't it so?
Yes, sir.
Second equation will be same.
Yes, sir.
देखो कुछ इक्वेशन तो बोलो ना, मैं लिखता हूँ इधर.
V minus V1 by R.
V minus V1 by R equals V1 by
V1
R.
minus V2 by R.
Is it okay?
V1. Yes, sir. Okay.
और एक थर्ड इक्वेशन भी लिख सकते, बोलो. Same as
2 into V.
2 into
Yes. V minus V2 by
R is equal to
R. 2 V2.
now solve it, you'll get your answer. And whoever got the
7
answer,
R by 5.
Amma?
7 R by 5. 7 R by 5.
7 R by 5. Others? Possible?
Yes, sir. 7 R by 5.
This answer I don't remember. You need to tell me. I just made it up here. I don't remember doing it. recently. So I don't remember the answer for that.
Sir, the difference is we don't add up 2b by r, sir. The connection between A and B.
The difference is only there. You will not write 2b by r. So if your calculation is right, the answer is right.
Yes, sir.
Children, Chinmay, are you there?
Yes, sir.
Akash, are you there, Akash?
Sir.
Right. So I'll go for the next question, children. Let me see. Time is there. Okay, I'll just give the question. Where are we now? Why did it go like that? Okay. Simpler one I'll give you. Sorry. Have you understood it? A pyramid shape.
Yes, sir.
So each is R. In this also, I'll give you a simpler one between A and B only. Come on. Each is R. Simpler one this is. You do and just I told you all, take a risk of doing some mistake. Take a risk of doing a mistake. Come on. Children. Himanshi, are you there? Gone.
I'm there, sir.
Tell me, dear, what should I do?
At A plus V, at B minus V.
Plus V minus V. Are you justified in this?
Yes, sir.
Can you tell me how we are justified?
It is symmetrical.
Yeah. Like if I put okay, there. All right. Let us continue. After that.
Opposite to A plus V1.
Plus V1.
And opposite to B minus V1.
Okay. Then the top.
Plus V2.
0 nahi rakh sakta main idhar?
We can.
Yeah, because plus V2 minus V plus V1 to minus V.
Yes, sir.
If I break it also, child, look. This one, of course, you'll write once again the what you call the Kirchhoff law and do it. But in this particular case, supposing I break it also, it will be still remaining 0, no? Oh, apex may. Just I can bring this down like this if I want. Which one am I bringing? This one. At the apex I am breaking and bringing this one here. I don't know whether you understood.
Yes, sir, understood.
Removing this.
And shifted it down.
Now probably this becomes easier now. How? Because between A and B I wanted, no? So is it becoming a series parallel circuit?
Yes, sir.
That will be 2R. This will be 2R, and in parallel with this R, how much is that?
2R by 3.
2R by 3. Plus R plus R. 8R by 3.
Yes, sir.
This is 2R. Right? So this 2R, 8R by 3 and R are in parallel.
Yes, sir.
So 1 by R effective equals 1 by 2R plus 1 by R. Actually, I could do simply 2R into R, 2R by 3 also I can do straight away. But anyway, I'll write everything. Then what? All this was 8R by 3, right?
3 by 8R.
3 by 8R. So what is LCM?
8R.
Hmm.
Eight R by 15.
That's why I told you it's a simpler one. But you can still apply that junction rule. You need not have to really think like this. There's no need. That is the basic. That will never ditch you. It will always give you an answer. For a completely new question, remember, people get the answers by putting basics. Believe my words in this. Actually, the whole thing is, children, for a completely new question, if you're able to apply a method, then you are come to the actual state of affairs. You know, even for me, for you, everybody, believe me, it's nothing, no difference between anyone. So 8R by 15. But as I told you, you can also just write it by what? Series? Sorry, this one. Junction rule you could apply without breaking and bringing like that. All right, children. So can I close this now? I'll be closing this. Tomorrow we'll do again. It's not over yet. If you speak, I'll do more problems. If you don't speak, I cannot.